Everybody always says the world doesn't revolve around you, you're not the center of the universe. But it kind of does though, and I kind of am. Let me explain. Just think about it and immerse yourself into my thought process just for a couple seconds, plus like 9 more minutes. The only life that you know 100% is your own. So yeah, when people say the world doesn't revolve around you, they mean in their world does not revolve around you. But the second digraph is silent. In their world, the world does not revolve around you, but the world does revolve around you, specifically from your perspective, because you are the one perspective that you truly understand. Nobody could really understand what it's like to be you, even if they were the coldest copy of you. They're not on top of your feet. It's impossible. There's too many factors. It's like how we once believed that the solar system was geocentric, but actually realized that it's heliocentric. But newsflash, their world does revolve around you because we live in a black hole, possibly, perhaps, perchance, maybe, allegedly. And the singularity or point of infinite density in this black hole would be everything or nothing or a bagel all at the same time. So we are all at the same time the center of the universe, allegedly, possibly, perchance, perhaps, maybe. It's all hypothetical, but I would like to connect with you guys by immersing us into this theory and the real life factors that go hand in hand with said theory. It is completely possible by math that we live, breathe, shit, fart, and do anything in a black hole. This is all gonna tie back together. Trust me, you just gotta work with me. Let me cook.
There's a supermassive black hole at the center of every galaxy.
Yeah.
But there's also other black holes that aren't necessarily in the center of galaxies.
The center of our galaxy is a black hole. So we have black holes within black holes. Sagittarius A is possibly another universe. Hear me out. Let me cook. Just trust me. It's going to tie together. Trust me, it's going to tie together. The interior and exterior of a black hole are relatively the same. So let's say we were to discover and measure and map a black hole with, let's say, a magical space telescope that is launching in 2035. We could be seeing the exterior of another black hole from the inside of our black hole, while also finding evidence of other black holes that are distorting everything with giant waves. Enter LISA, the laser interferometer space antenna. The aforementioned magical telescope, it is a gravitational wave detector, and gravitational waves are produced by black holes. That whole preamble was very important because we possibly live inside of a black hole. Hear me out.
The universe is constantly expanding. Then what is it expanding into? Ooh.
It's one of the biggest questions of all time, right behind where did we come from and where did the creator come from? The edge of the universe literally grows as we look for where it ends. So hypothetically speaking, we could live in a black hole. Hear me out. Trust me, it's gonna tie together. In theory, possibly, perhaps, perchance, maybe. Let's explore a little deeper. Also, I'm just saying that the tree of life and the side profile of a black hole look exactly the same. In theory, it makes sense, and here's where the math starts, and I promise it's not boring. Stick with me. Hey, the back rooms?
Jingle, jingle, pay attention.
Yeah, okay, so you can use the black hole equation, and if you want to, it'll tell you for some given amount of mass, how small of a volume you'd have to pack it in to make a black hole. So for example, my astronomer friends are very, very good at calculating what the total mass of the observable universe is. I put it into the equation that says how tightly I would have to pack that. You'd think it's something like the size of a galaxy or something like that, right?
Right.
But it turns out that the observable universe would need to be packed into a volume that is already larger than the observable universe.
That's weird.
If you say that's weird, it's because it is.
Okay, now my mind is blown.
Fun fact, a lot of space is empty and spread out very far apart from each other. Infinitely expanding, but infinitely falling to a point of infinite density. So this is all theory, right? But how do we detect black holes right now in practice? Lots of science and math that was once thought to be delusional, but everything's delusion until you actually do it. Everything that was once seen as impossible was only impossible until someone really, really smart came along and figured it out. To truly detect if we live inside of this black hole, this petri dish of the universe that is a black hole, possibly, perhaps, perchance, maybe, allegedly, we're gonna have to go beyond earthbound telescopes. Which brings me back to LISA, a future space probe that will detect gravitational waves, but from space. It's the first of its kind. Gravitational waves are a literal ripple in space-time, and the instrumentation that we have on Earth is just not powerful enough to detect the types of waves and reliably and accurately do the same things that LISA will do. It's just, the scale is just It just doesn't make sense. Even with our current ground-based version called Laser Interferometer Gravitational Wave Observatory, just for reference, humans are recorded hearing at 20 to 20,000 hertz. So 20,000 hertz is 20,000 vibrations per second, and 20 hertz is 20 per second. And Lisa is capable of detecting 0.1 hertz to 1,000 hertz, when a human voice is around 25 to 650 hertz. This is essentially the same as standing at the Hudson River and hearing a whispered conversation at the edge of the United Kingdom. This is accomplished by using lasers, mirrors, kilometers worth of piping and wires, centuries of STEM development, plus all the factors that we can't see, like literal extra dimensions. This combination is a very large scale of interferometry. So to extrapolate this acronym LISA into a more digestible and understandable way, space antenna that uses light amplification by simulated emissions of radiation bouncing off platinum mirrors over astronomical units to detect gravitational waves by deconstructing interference between two combined signals. That blip on that chart is a distortion in space-time accurate down to the nanometer, thinner than a human hair. The way LISA functions is very similar to the Event Horizon Telescope and LIGO, because with astronomical setups, at least 2 telescopes are required, as the distance between them is effectively the size of your telescope lens. With the Event Horizon Telescope comprised of 10 different locations around the globe, it's essentially an Earth-sized satellite. It has a dish diameter of roughly 7,900 miles. It can detect something about 540,000 miles wide, which is an insane metric, and it recently captured Sagittarius A at the center of the Milky Way. Okay, so you heard that right, but imagine the Earth, right? Now make it 333,000 times bigger, right? It's pretty big, right? Okay, now multiply that by 1 billion.
Oh my God.
That's how big LISA can detect. Still cannot detect your mom. Okay, now this is how LISA works, kind of. This is how laser interferometry works. And if you can't imagine an apple spinning in your head, this is going to be a lot more difficult, but I'll try and put it into a way that can be digested. You shoot a laser, split the laser, bounce the lasers back at each other, and recombine the laser. And then you cancel out frequencies and look for interference. So that peak, like I said, is a distortion in space-time accurate down to the nanometer. That's gravitational wave detection the simple way, because we didn't even get to pulsar timing arrays yet, and I'm not going to talk about that. So now you heard about laser interferometer. Laser interferometer space antenna. LISA is comprised of 3 separate pieces in an equilateral triangle, with each point 1 million miles away from each other. Effectively, the dish is 12.6 thousand times bigger than the Event Horizon Telescope. So if I were to encapsulate that into one sentence, big ass laser light show that detects anomalies in space-time while also moving at 17,000 miles per hour.
Jingle, jingle, pay attention.
LISA's primary objective is to detect and measure gravitational waves produced by compact binary systems and mergers of supermassive black holes. It does this by observing gravitational waves and measuring differential changes in the length of its arms. Each of the 3 spacecrafts contains 2 telescopes, 2 lasers, and 2 test masses, gold-coated cubes of platinum, by the way. And the entire arrangement is 10 times larger than the orbit of the moon and will be placed in solar orbit at the same distance from the sun to the Earth. The mean linear distance between the formation and the Earth will be about 50 million kilometers or 1 million miles. These 3 spacecraft flying in a big equilateral triangle in formation, the detection principle of these spacecraft literally reminds me of a brain and eyes. There's 2 detection sites or transponders and 1 observer. It also works in tandem with the Advanced Telescope for High Energy Astrophysics, acronymed Athena, who is the goddess of wisdom and knowledge. And it uses these detection sites with the emission and intromission theory of vision. 2 eyes/transponders that receive visual signals transmitted to the observer/brain, plus Athena, knowledge, is finding the singularity. If it does happen to be at one point and not everything everywhere all at once, or nowhere at the same time, or inside of an everything bake. Hashtag Lisa and Athena are a brain and eyes. It's kind of like how Bluetooth receivers can transmit through walls because of the wave frequency being super low. But the wall is a solar system, the width of 3 light years, and instead of Bluetooth, it's a space mirror maze that detects anomalies in space-time at 17,000 miles per hour. It's pretty simple, right? Wrong. Enter LISA, the Laser Interferometer Gravitational... No, fuck, that's LIGO.
And again, it's a good question where when we say the Big Bang happened 13.8 billion years ago, you could ask the question, where did the Big Bang happen? The Big Bang happened everywhere. So really the singularity in our universe, if we live inside an enormous black hole, the singularity happened everywhere at once. It's
The singularity is all of us.
is everything.
If I can see if I'm understanding this, it's not where is the singularity, it's like when is the singularity almost?
Yeah, that's a good way to think about it.